Okay, our next topic is polynomials. So a polynomial is a function that can be written in the form that we can see here. So we've got p of x. So they've just decided to call this function p, as in a polynomial. And then you'll have a, so if you have a look here, you'll have a term and it will have a power. And then you have your next term, which will have a power that's lower than the first. So if you think about it, a quadratic is actually a polynomial. So if you had, say, 2x squared plus x plus 3, so we can see this is a quadratic because the highest power is a 2 on thing. But can you see, if you look here, this x here has a power of 1. So you can see it is one less, one less than 2, which is shows. So we have been doing polynomials as such. We've done quadratics, but now we're going to move into all other ones, and we're mainly going to concentrate on a cubic, which a cubic is when we see a the highest power is a cube. So we might get an expression like, say like this. So we can see the highest power is a 3 if you look in that thing, and that's known as the leading term. So we've set up here, so if you look down in the red here, we can see that the highest power is a 6, so that would be the leading term. And then we've got some other ones there. So the number without a letter or a coefficient is known as the constant term, and you can see that that's like 2. So up here on that one I drew up here, 8 is the constant, and x to the power 3, that's a leading term. And we're going to be looking a lot at cubics and the thing. So the degree of the polynomial is the index of the leading term. So the degree of a cubic is 3. The degree of a quadratic is 2, and say here in this red example, the degree of this one would be 6 because it has 6 is the highest power. Okay, if we have a monic polynomial, that means the number or the coefficient of the leading term is 1. So up here in that red, that's not a monic because the highest leading term is this one, and the coefficient is 2. So for an example of a monic polynomial is like the one I've written up here. This cubic one is a monic polynomial because it has, in the leading term, the 3, it's assumed a 1 there. See, 1's the highest power. Okay, so now we know a polynomial is pretty much a type of function. So here, if we had a look at this polynomial in the example, or the function is x to the power of 4 minus 3x cubed minus 2. Now, if you had a quick look at this one is a monic polynomial because there's a 1 there, and it has a degree of 4 because the highest power is a 4. Okay, so if you are asked to find p of 1, we've sort of done these in function. All you have to do is everywhere you see an x, you'll put a 1. So p of 1 is equal to 1 to the power of 4 minus 3 x to the power, 1 to the power of 4, 1 to the power of 3 minus 2. So that ends up being 1 minus 3 minus 2. So that equals negative 4. Okay, so if we get p of 2, all you have to do is everywhere you see x, we'll put a 2. And then you work that out. So 2 to the power of 4 is 16, minus 2 to the power of 3 is 8, times 3 is 24, and then we work all that in, and we end up with negative 10. So we've sort of done them, so they're pretty easy. So we could go, if they told me, so let p of x equal this formula here, plus 6, And they're telling me that p of 1. So that's sort of saying if x equals 1, this whole term will end up being 21. Now find the value of c. So we can see we have c in there. So let's do p of 1 like we did before. So every time I see an x, I'll put a 1. So minus 1 to the power of 3 plus 2 times c times 1, because there's an x, plus 6. So if we keep simplifying that, so that would be 1 times 2, so it's 2 minus 1 plus, now if I do this, this would be 2c plus 6. Okay, so that's what p of 1 is, and if we tidy that up, we could get p of 1. We're going to add all like terms. We get that it is 7 plus 2c. Now, we know that p of 1 equals 21 because they told me that. So, I could say 21 equals 7 plus 2c. And then we'll keep rearranging. So, we get 21, minus 7 equals 2c. So, we get 14 equals 2c. 14 divided by 2. So, c equals 7. Okay, and then we have our answer. Okay, with this next question, they've said let q of x, so this is a polynomial, but they're calling the function q, doesn't matter what they call it. Okay, so they're letting it be 2x to the power of 6 minus x to the power of 3 plus ax plus bx plus 20. So there's our function formula. And now they're saying if we put, when x equals -1, we get the function equaling 0. And we also say if we let x equal 2, we get that function equaling 0. So they want us to find the values of a and b. So if you have two unknowns, you should be able to set up two equations, and we're going to solve them simultaneously. Okay, so let's do that. So let's work out what q of -1 would be. So everywhere I see x, I'm going to put a -1. Okay, so I'm doing that here, plus b times -1 plus 20. Alright, so if we keep simplifying that. Now, -1 to the power of 6, if you've got a negative number to a power of an even number, which is 6, you're going to get a positive. So we would have 2, that'd be 2 times 1, so that's 2. Now, this is -1 to the power of 3 is -1. Okay, so -1 squared is 1, so you'll get a times 1. And then you're going to get minus b plus 20. So if you fix up, that will be 2. Now these two minuses become plus 1 plus a minus b plus 20. So if you group all, plus 1, you group all that, you get 23 plus a minus b. Okay, so there is, and we've got that's q of -1. And we know that that equals 0 because they told us in the question. So we could say there we have one equation set up. So we've got equation, I'll just call it equation 1. So we can do the same thing now with q of 2, and we're going to get our second equation. So every time I see x, I'm going to put, it was minus. I'm going to put a 2 plus a 2 squared plus b times 2 plus 20. Okay, so if we work out that 2 to the power of 6 is actually 64 minus 8 plus, that would be 4a plus 2b plus 20. Okay, so 2 times 64 is 128 minus 8. So we're going to keep on simplifying. Okay, we're going to group all like terms, so that would be here. So I'm going to end up with 140 plus 4a plus 2b. And that's what Q2 equals, but we know that that equals 0. So we've got 140 plus 4a plus 2b. Okay, and so here we have equation 2. Okay, so we're going to use those two equations to solve simultaneously. So we have 0 equals 23 plus a minus b. That's the first equation. And I've got 0 equals 140 plus 4a minus, plus 2b. Alright, so we want to know when we add these two equations together, we want to be able to eliminate one of them. So the only way we can eliminate one is if they're the same. So if I times that by 2, when I add these, the b will get eliminated. But because I've times that by 2, I have to times everything by 2. So that equation ends up being 0 equals 46 plus 2a minus 2b. And if I just rewrite this one again underneath, I've got 0 equals 140 plus 4a plus 2b. Now we can see when we add these, it eliminates the b. So I have 0 equals 186 plus 6a. And you can keep rearranging, so I could move the 186 to the other side and 186 divided by 6. So we get negative 31 equals a. Okay, now we know a. I can use any of the equations, which I might go back and use equation 1. So I'll write 0 equals 23 plus a minus b. But I know a is actually negative 31 minus b. So you end up with b equals negative 8. Okay, so there we've solved those two equations. Or we've solved for a and b. Okay, so if they're saying here, let p of x, so p of x equals that, x cubed minus 6x plus 3, and q of x equals that. When they ask you to find p of x minus q of x, all you have to simply do is write what the actual functions are, and you're actually taking it away. So that first one I've just written is px, and we want to minus the q function, which is x squared minus 3x plus 1. Now, see, I've put it in a bit of a square brackets because you need to be careful, because when you minus a minus, it becomes a plus. So if I simplify this out, I'm going to get minus x squared. Now it's going to be plus 3x minus 1. And now I'll keep grouping like terms. So I don't have any other cube terms. And I don't have another square term, so I'll leave that one. I've got a negative 6 and plus 3x, so that becomes that. And I've got a 3 and a negative 1, so that becomes plus 2. So that's simply the answer to that. So when we're going to add them, we're simply going to add the functions. So it's the same thing. There's the p of x. I'm going to add q. Okay, so expand that out. So plus x cubed minus 3x plus 1. Oops, sorry, that's squared. Okay, so we end up with x cubed plus x squared minus 9x plus 4. So that's what that one equals. Now here, this just simply means we're going to times. So we are going to times p of x, which is x cubed minus 6x plus 3. And we're going to times it by x squared minus 3x plus 1. So you could, if you were doing this manually, we are going to have to multiply everything like that, and then you'd get your next term, and it would have to get multiplied with everything, and then you'd get your final term, and it would have to be multiplied. So you could practice your expansion, but we could probably use our calculator on this one. So we might do that. Okay, when we try to do these in the calculator, like, you can define your functions like we have been doing. So here I've defined the first one, p of x. So in your calculator you do define, and you can get that by pressing, if you remember, define is done by doing menu, actions, and define. So you get the word define, then you type this in and you press enter and it should say done. Then we're going to define the next one. So we write q define with the menu actions define. Then we type this in, q of x equals blah blah blah, and we write enter and done. So now it's got the 2 stored in. So if you really wanted to, you can check your answers over here. So you can type p of x minus q of x on the calculator, and you should get your answer that we got up here. Alright, so we actually want to times them. So I'm going to do p of x times q of x, and I press enter. And all it does is actually write those 2 functions times together in brackets, that's okay. Well, now we want that to expand. So we're going to use the expand function, and that is in menu, algebra, and expand. You select expand, and then you can just type this in, or just press up and highlight it and press enter, and then you get the expanded version. So it's probably a good chance to practice your calculator skills there. Okay, so what we're going to do, we've got the polynomial p of x is equal to x to the power 3 plus 3x squared plus 2x plus 1. And it can be written in this form here, where it's x minus 2 bracket times by x squared plus bx plus c plus r. And they're telling us that b, c, and r are real numbers, and we need to find their values. So what we're going to do is we're going to expand the bracketed version. So this x minus 2x squared plus bx plus c plus r, we're going to expand it so it looks like the first version they gave us. So when I mean that, so I mean this version up here, that's what we're going to expand it so it looks like that. So let's go about expanding. So when we expand, remember we have to times each term by that, and then that 2 will have to be. So if we do that, we get x to the power of 3, then x times bx would be plus bx squared plus x times c, cx. And now I'm doing the 2 part, so I get negative 2x squared minus 2bx minus 2c, and we didn't have to do anything with the plus r. Okay, so if we were fixing that up, we would group like terms. So we have a like term here and a like term here. So we'd write them next to each other, and we'd also group these because they're both x's. So we put plus cx minus 2bx, and we've got minus 2c plus r. Okay, so if you have a look here, I'm just going to group these guys. Alright, so if I take out what's common, x squared is common, so if I took out x squared, I would be left with b minus 2, and I'm just going to put the x squared there, because now you can see this is the coefficient of the squared term, so that is 3. Okay, and if I do that for the next thing, so I'll group these two, so x is common, so had I taken x out, I'd be left with c minus 2b equals x. So this number, this is equal to the coefficient up here, which is equal to 2. So that's equal to 2. And this one's the number in front of the x squared, so that one's equal to 3. And then we have that this negative 2c minus r must be equal to 1. So let's do the first one first. So we know b minus 2 must equal 3. So b equals 5. So I know that. And then I know that c minus 2b equals 2. So we keep, but I know that b is 5. So c minus 2 times 5 equals 2. So c equals 2 plus 10. So c equals 12. Okay, and now I can use this one. So negative 2c plus r equals 1. But I know that c is 12. So at negative 24 plus r equals 1. So r equals 25. So it was a little bit tricky, but there you go. Okay, I've just written a couple of the expansion patterns that you are going to have to remember, or it makes a lot easier if you can remember. So instead of, say for this top one, instead of having to write out the 2 brackets and then do all the expansion and so on, it's quicker just to remember that it's always this pattern. And we've got a few new ones here. Some cubics will always expand out like to that, and then something to the power of 4 will expand out to this. So it can be handy if you remember them. So we've done plenty of these quadratics, so we're not going to do an example. So I'll do one of these cubic. So we know, looking at the pattern, it's the first term cubed plus 3 times the first term squared times the second term, which is 3. Then we do 3x and we times 3 squared, and then plus 3 cubed. So if you quickly tidy that up, so 3 times 3, so that becomes 9x squared, and this would be 3 times 9, so that's plus 27x plus 27. Okay, so just following that pattern. Here with the fourth one, so